I'm just going to go through the first practice gateway posted. So 2 square root of x plus x is our first integral. So whenever you see the square root of x, you want to think of that as x to the 1/2. So this integral is going to be, so x to the 1/2, we increase the power by 1, and then we divide by that constant. So divide by 3/2, or just multiply by the reciprocal, which is 2/3. And then that 2 just kind of comes along for the ride when we do antiderivatives. So I could simplify this to 4/3, x to the 3/2. And then the integral of just x is going to be x squared divided by 2. And then this is an indefinite integral, so we put a plus c at the end. When we do the integral of x, again, we'll get 1/2 x squared. E to the 3x. The derivative of e to the 3x is 3 e to the 3x. So we multiply by a 3 when we take a derivative, so we have to divide by 3 when we do an antiderivative. So minus 1/3 e to the 3x. And then the integral of ln of 1 over x is natural log of absolute value of x. And again, this is an indefinite integral, so we do a plus c at the end. Sine of 2x plus cosine of 3x. So the integral of sine of 2x is equal to negative cosine of 2x. And when we take the derivative of cosine of 2x, we would get negative sine of 2x times the derivative of 2x, which is 2. So we would end up multiplying by a 2 when we do a derivative. So when we do an antiderivative, we have to divide by 2. So I'll put that negative over there, and then I'll divide by 2. So negative 1/2 cosine of 2x. Similarly, the antiderivative of cosine is going to be sine of 3x. And then we divide by 3 here, because again, same reasoning. When I do the derivative of 1/3 sine of 3x, I'll get 1/3 cosine of 3x times 3, and the 3's will end up canceling out when you do that derivative. All right, and then this is a definite integral from 1 to 5. So now I need to plug my bounds in. So I'll do negative 1/2 cosine of 2 times 5, which is 10, plus 1/3 sine of 3 times 5, which is 15, and then minus, put this all in parentheses because we need to subtract everything. So negative 1/2 cosine of 2 times 1 plus 1/3 sine of 3 times 1. X squared sine of x cubed. When you're doing these things and you don't know immediately what the antiderivative is going to be, your first hope is that you can do a u sub on it. So immediately when I see this, I'm like, oh, I don't know how to do this derivative. I immediately try to decide, like, is there a u substitution that I can do in this problem to solve it? And so making u be x cubed is going to work for this one. So if u is equal to x cubed, then du is going to be equal to 3x squared dx. And this is good because the x squared dx shows up in the problem over here. X squared times dx is kind of split up apart a little bit. This 3 isn't there, but we can just divide by 3 on both sides here because 3 is just a constant, and then we can go from there. So 1/3 du is equal to x squared dx. And so we can now replace x squared dx with 1/3 du. All right, so our integral becomes the integral of sine of u times 1/3 du. I'm going to put the 1/3 out in front. The integral of sine of u is negative cosine of u. I'll bring the negative in front, plus c. And so this is negative 1/3 cosine of x cubed plus c. All right, next problem, sine to the 5th x times cosine x. Here, again, you want to think, is there a u sub that I can do here? And here, a u equals sine of x is going to work great. So du will be cosine of x dx, and that just very nicely shows up over here in this problem. So this integral becomes the integral of, instead of sine to the fifth, it's u to the fifth times du. And the integral of u to the fifth is u to the sixth divided by 6 plus c. And now I just replace back in for sine of x. So this is sine to the sixth x plus c. Just change colors just for, because why not? All right, cosine x times e to the sine x. Here I'm gonna do another u sub. Whenever I see like e to the sine x, like something like that, like sine of x is sort of your inside function, so it's kind of a good hint that you might want to do a u sub, because u sub is like undoing the chain rule where you have like your inside functions. So du is going to be the derivative of sine, which is cosine of x dx. And so this integral becomes the integral of e to the u du, because this cosine x dx just gets replaced with du, and this e to the sine x becomes e to the u. And what are our bounds going to be? Yeah, let's figure out what our bounds are going to be in terms of u. If x equals 0, u is equal to sine of 0. Sine of 0 is equal to 0. If x equals 5, u is just going to be equal to sine of 5. There's no way to simplify that. We'll just leave that as sine of 5. So this is 0 to sine of 5. All right, so the antiderivative of e to the u is just e to the u. And it's from 0 to sine of 5. And so this is equal to e to the sine of 5 minus e to the 0. E to the 0 is equal to 1. You could simplify that if you want. I don't really care. All right, let's do black now. So x squared e to the x. This one, probably going to need a little bit more room for this one. But let's just do it. So we're going to have to do integration by parts on this one, because there's no u substitution that we could do here that'll really work. Like if you made u be like x squared or something like that, then like 2x dx doesn't really show up anywhere in the problem. And there's not really any other good choices of u there. So we're going to do integration by parts. So we have to pick a u and a dv. So I'm going to pick my u to be x squared and my dv to be e to the x. My du will be 2x dx, and my v will just be e to the x. There should have been a dx there. All right, so my integral becomes u times v minus the integral of v times du. So 2x e to the x dx. And this, right here, we're going to have to do another integration by parts on. Let's give me some space over here. So I'm going to pick u to be 2x, my du to be e to the, or sorry, that would be dv, my dv to be e to the x dx. Then my v will be the antiderivative of e to the x, which is just e to the x. My du will just be 2 dx. All right. So then this equals x squared e to the x minus, so uv, 2x e to the x, minus the integral of v du. And v du, it's not good. Do this. All right, so this is my uv minus the integral of v du. Go away. V du, v is e to the x, du is 2, so I get 2 e to the x dx. All right, and all this is being subtracted. So this is x squared e to the x minus 2x e to the x, and then plus the integral of 2 e to the x, which is just 2 e to the x. And then this is an indefinite integral, so I just have a plus c at the end. All right, getting messy a little bit. We're gonna have to go into the next page here. All right, Integral from 1 to 2 of ln of x over x squared dx. So this is almost a u sub problem. If I did u equals ln of x, then my du would be 1 over x dx. And this is very close to appearing in the problem. If this was ln of x over x dx, then this would be a u sub problem. But because of that being an x squared, then the u sub is just not going to work in this problem. All right, so we have to do integration by parts. So I'll do u is equal to ln of x, and my dv is equal to 1 over x squared, or I'll write that immediately as x to the negative 2 dx so that I can integrate it better. And again, ln of x would have been a bad choice for my dv, because if I made that my dv, then I wouldn't know how to integrate it without having to do a different integration by parts problem. So this is pretty much the only options that we have. So my du is the derivative of ln of x, which is 1 over x. My v is going to be x to the negative 1 divided by negative 1, so just negative x to the negative 1. And so I get the integral is equal to, or my antiderivative is equal to uv, which is negative x to the negative 1 times ln of x. There should really be absolute values around here. And then minus the integral of v du, which is negative x to the negative 1, which is, yeah, I'll just write that x to the negative 1, times 1 over x, should be a dx over here. 1 over x is equal to x to the negative 1, so I'll write that as x to the negative 1 as well. And so this equals negative x to the negative 1 times ln of absolute value of x. These two negatives become a positive, so plus x to the negative 2. When you multiply these two things, the exponents add, dx. And when you integrate x to the negative 2, the exponent goes up by 1, so x to the negative 1, and then divided by negative 1, so it should actually be minus x to the negative 1. So that's my antiderivative. So the integral from 1 to 2 of this whole thing is equal to this whole thing when we plug in 2, and then minus when we plug in 1. So let's do that. So negative 2 to the negative 1 times ln of 2 minus 2 to the negative 1. And then minus, so I'm going to subtract all the terms. When I subtract this entire thing, I'm just going to make everything positive. So I'm just going to write plus 1 to the negative 1 times ln of 1, and then plus 1 to the negative 1. So if you don't want to put parentheses here, just make sure to change the sign of all of the terms in this so that you're like distributing that negative. All right, and so this would be your final answer. You could simplify this too if you wanted, like this, like 2 to the negative 1, that's the same as like 1 over 2. 1 to the negative 1 is 1 over 1, but really that's just equal to 1. Ln of 1 is equal to 0, so this whole term is equal to 0, and then this would just be 1, right? So you could simplify it. I don't particularly care if you do or not, as long as you have like your parentheses and your signs and everything right, and you have your plus c's whenever you're doing indefinite integrals, you should be good.